Hi everyone, welcome. My name is Ronald Prasad and I'm the Microsoft Services Principal here at Critical Start. And today we're going to talk about our Azure Sentinel projects. A little about Critical Start. So we are the industry leaders when it comes to manage detection and response services. We provide this MDR service for a variety of security products out there, such as Azure Sentinel and the Microsoft 365 Defender products. We also do provide Microsoft cybersecurity consulting services as well, through which we deliver educational workshops, security assessments, basically helping customers correctly design and implement Microsoft security solutions in their environment. We are also a gold Microsoft partner as well and a member of the Microsoft Intelligence Security Association as well. Okay. So the projects we're going to talk about today are going to be more aligned with the IoT industry, the Internet of Things industry. These projects are going to help customers to effectively use Azure Sentinel in their IoT environments to do better detection, monitoring, and response. So these are the two projects that we're going to talk about today. The first one is going to be a Azure Sentinel solution for the Defender for IoT. And then the second one is going to be the Azure Sentinel IoT Lab environment. The second project basically gives the customers to create a isolated lab environment where they can test the latest IoT attacks and then use the environment to do SOC training, use the controlled isolated lab environment for blue team, red team type of exercises. Okay. So as part of this part one recording, we are going to talk about the very first project, which is going to be the Azure Sentinel solution. We're going to be doing a part two of the recording as well, which is going to be about the second project, which is going to be the IoT lab environment. Okay. So let's talk about the first project here, which is going to be the Azure Sentinel solution for Defender for IoT. Defender for IoT has been out for many years. It's a Microsoft product for you to use in your IoT environment to do attack detections, etc. Okay. It is basically a standalone solution, basically a sensor that you deploy in your IoT networks, and then it basically does a deep packet analysis and does detection for your IoT environment, detects any IoT attacks, etc. Okay, so since it's been out for many years now, it actually has a existing data connector in Azure Sentinel, right? But there is some limitations for that particular data connector. So right now, Defender for IoT alerts stream into Azure Sentinel using two data connectors, which is the Azure Defender data connector and the Azure Defender for IoT data connector, right? So there's a little bit confusion between which data connector to use when, and then not all alerts generated by Defender for IoT gets synced into Azure Sentinel. Okay, so those are the two limitations. And then there's a third limitation as well. For the alerts that do actually get synced, they are missing metadata. Right? For example, here we see a alert type, which is excessive login attempts, but we don't get any entity information. So we don't know which IoT device this particular alert is related to, what is the IP address of that IoT device, what subnet it's part of, etc., making investigation and response very difficult. And then here are a few other examples. The last one is also a great example here. Unauthorized internet connectivity detected from by Defender for IoT, right? So Defender for IoT is alerting that there's a unauthorized internet connectivity in your IoT network, right? But since we don't have any entity information, we don't know which device is trying to connect to the internet, what the IP address for the device is, etc. So we cannot easily go ahead and investigate that particular alert or perform incident response for that particular alert. Okay. So in order to help with this, right, we came up with a new Azure Sentinel solution that has multiple components in it. Basically, it is everything that you need in order to collect alerts correctly from Defender for IoT, sync them into Azure Sentinel, correctly parse those alerts into Azure Sentinel and create incidents out of it, correctly populate all of the incident metadata that you need to do proper investigation. So basically do proper entity mapping and all that in order for those entities to be used by the UEBA feature, the anomaly detection feature as well, and also give us the ability to do advanced investigation. And then we're providing some automation playbooks as well, and some Azure Sentinel workbooks, which is aka interactive dashboards. Okay. So this is the whole solution. What I'm going to do is now break this down into individual components, and we're going to do deep dive into the individual components, how they actually work, and basically help you understand how this entire solution comes together when you deploy it in your Azure Sentinel environment. Okay. First thing we're going to talk about is going to be how do we actually collect the alerts generated by the Defender for IoT and sync them into Azure Sentinel. So the data connector we went with is the common event format data connector. Why? Because many of our customers, they already have a bunch of network appliances in their environment. So these are things going to be like firewalls, IPS, IDS, right? Which in order to get the logs from those solutions into Azure Sentinel, you already have a syslog server deployed. You're already using the CEF data connector to sync those logs into Azure Sentinel. So we used the same existing logic. Since Defender for IoT is also a network appliance, it supports log forwarding to a local syslog server, and that worked out perfectly for us, right? So now, by using Defender for IoT, sensors capability to do log forwarding to a syslog server, and then the Azure Sentinel CEF data connector collects those logs and alerts and actually syncs them into the log analytics workspace that Azure Sentinel is running on. When the alert logs actually comes into the log analytics workspace, we see that they provide a ton of value. Defender for IoT actually provides very, very rich alert data. As you can see, all of the entity information such as destination IP, source IP, MAC address is all available as metadata inside of this alert log. Some of the fields are correctly parsed, such as the message field and the activity field we see here. And then there are other fields that are not correctly parsed. The data is there, but it is either embedded in a field as a array or as a string, right? So for example, here the additional extensions field in this alert log contains a bunch of additional information that we would really want to expose as individual fields by themselves so that we can further query against them, right? So I want to go ahead and further extract the source IP, destination IP from this string field and expose them as fields of their own. Okay, so in order to do that, we are providing a Azure Sentinel parser that you can use. Once you install the parser, it takes literally 30 seconds to do. The parser is actually going to go and parse all of the nested fields, all of the nested arrays, all of the nested strings, etc., and then make sure that each of those important values are actually provided as fields that you can query against, right? So that is the parser that we're providing. And after the data is normalized in Azure Sentinel, well, the next thing the solution needs to do is actually create incidents, right? Based on the alerts that the Defender for IoT is generating, we want to go ahead and create incidents out of them so we can actually do the incident lifecycle management in Azure Sentinel, which is going to be investigating the incident, assigning to your SOC individual, and then doing the incident response and closing out the alert, right? Okay. So for that, we really gave a lot of thought around the detection rule to use in Azure Sentinel, because Defender for IoT actually has the capability to generate hundreds of different alert types. And we really did not want to go out and create hundreds of detection rules in Azure Sentinel. So what we went with is the Azure Sentinel's capability to add dynamic content in the analytics rules, right, which you see at the bottom here. So instead of creating hundreds of analytics rules, we created one analytic rule which has the ability to dynamically populate details based on what's available in the alert data coming from Defender for IoT, right? So if Defender for IoT does detection, creates a alert of type A, well, the type A information is going to be populated in the incident when it's going to be created by the rule, right? And if it does or generates a alert B type B alerts, then it is going to be populated using the type B alerts data. And so basically, ability to fetch dynamic fields and create incidents based on dynamic fields in Azure Sentinel is one of the best selling points for Azure Sentinel, and we are making good use of it here in the detection rule that we are providing. And in the detection rule, we are also doing correct entity mapping, such as your source IP, your destination IP addresses for the IoT devices, so that now this information can be used by the UEBA feature in Azure Sentinel, used by the anomaly detection service in Azure Sentinel, etc. So that end of the day, you get more value of using Azure Sentinel in your IoT environment, right? Okay. And then the next thing here is going to be additional enrichment to the detection rule and the type of incidents is going to be able to create. Right, we are providing a template for a Azure Sentinel workbook. What the workbook actually does is gives you the ability to populate another field in the incidents, which is going to contain your actual Azure IoT Hub device registration names. So in the Azure IoT Hub, you have virtual devices that you can register, and these devices are actually synced with the physical IoT device on your environment. And then this is how the communication happens between the Azure IoT service and the physical IoT device you have in your environment, right? So in order to correctly populate or give you more context in the incident itself, right, so this particular workbook is going to help you do the alignment. So basically, you're going to provide in the source IP addresses on your on-premise IoT devices and which visual IoT device they talk to in the IoT Hub service. And then this information is going to be populated in the incident that's going to be created. Okay. So end of the day, it's going to give you more context in the incident itself, so you don't have to go on a blind hunt to find out which Azure IoT device registration that particular physical device is communicating to that has the alert associated with it. Okay, so now let's take a look at if you have all of these components from our solution deployed, which is the data connector, the parser, the analytics rule, and the workbook. Let's see what type of incidents these components are able to create for you for your Defender for IoT alerts in Sentinel. Okay, so now since we have all those components deployed, when an actual alert occurs in Defender for IoT, it gets generated, um, it gets populated into the Logintis workspace, the analytics rule in Azure Sentinel runs, and it produces a incident that you can investigate now. As you can see, the incident name field and the description field are going to be dynamically populated based on the different alert types coming from Defender for IoT. And then we have the entities information here as well, which is really, really useful, right? So we see the actual IP address of the IoT device. And then down here, we have all the additional metadata that we're exposing using that analytics rule. And then the most important one is going to be the actual Azure IoT service device registration, which in here is going to be the IoT device 3. So now I know that, hey, this is the physical IoT device that is related to this particular alert, and this is the virtual IoT device is communicating to in my Azure IoT service, right? So now I can do one-to-one relationship mapping. I know how to now go ahead and perform my incident response from here onwards, right? Which virtual device to target and which actual physical device to target. Okay, so since we're doing entity mapping, and you know Azure Sentinel provides you a rich investigation UI, which you can use to reconstruct the entire kill chain, right? And then that's exactly what the entity mapping gives you the ability to do. Since we have correct entity mapping, the UABA feature and the anomaly detection feature, and then the alert correlation features, they all make use of the data. So here, I'm not just investigating that one IoT device, I'm now investigating how that particular IoT device is actually related to all the other attacks in that IoT environment. The different timelines that attacks happened, the different attacks, the different severity levels, etc. What were the other entities involved in all that, right? So I can see the full relationship. I can reconstruct the entire kill chain just because the analytics rule we're providing does follow the Microsoft best practices for entity mapping. Okay. And then lastly here, we're providing you with a automation playbook so that after you have investigated that particular reach incident, now you want to go ahead and do incident response. And one of the best use cases for incident response is going to be you want to block off that physical IoT device from communicating to the IoT service, right? So you want to block it from communicating to your backend services, etc. Okay. And then so for that we provided a logic app that your SOC analyst can use on demand from Azure Sentinel. And then the playbook actually goes and disables the virtual device registration in the Azure IoT Hub service. So for example, here the device was enabled, now it's disabled. So what's this going to do? This is now going to actually terminate the communication between the physical IoT device with the virtual device that you registered in your IoT service. Okay, so that is going to be incident response capabilities. And then the last component that we're providing here as part of the solution is going to be the actual dashboard or workbook. Okay, so this is going to be a very rich workbook that is going to help you to first to analyze all of the different attacks happening in your environment and also help you prioritize where you need to focus your incident response capabilities at, right? So the first um, component in the dashboard, right? The first component in the dashboard is going to show you all of your IoT attacks grouped by subnet. This is really, really useful, right? So you know, hey, which of my subnets are compromised? How many alerts am I getting from the individual subnets? Which are the IP addresses that are compromised, right? And then the different severity levels and the alert counts, okay, based on the different alert types. So now this is going to give you the ability to now prioritize which subnet you need to focus on in terms of incident response, in terms of risk mitigations, etc. And then it also going to give you a good insight regarding your exposure levels, right? So which subnets are more exposed to different threats? Maybe you need to go and redesign that particular IoT environment or the network layout environment for that subnet, etc., in order to reduce the risk factor associated with that IoT subnet. Okay. And then the next component in the dashboard is going to give you the ability to look at the top operational related alerts in your environment. So these are going to be when maintenance is done on sensors, when the sensor goes unresponsive, when certain IoT commands sent to the IoT devices um, fails, etc. Right? So, for example, here RPC fault rejection type of alerts generated by Defender for IoT. You'll be able to see those underneath the top operational alerts. And then at the bottom here is going to be the top anomaly alerts, which is going to give you the ability to see what type of anomalies are happening in your environment, right? So all of a sudden, a particular IoT device starts doing port scanning in your environment or is having multiple login failures or is facing brute force attack. This particular component of the dashboard is going to help you visualize that as well. And it's going to give you which IP address or which IP address associated with the physical IoT device, IP address, and then the total count of that particular alert occurring in your environment, right? So as you can see, this particular dashboard gives you deeper insight into your IoT environment. And then using this insight, you can now actually prioritize which areas in your IoT environment you need to really focus on, where you're facing the most risks, and where you need to start implementing more technical security controls to prevent these alerts from happening again. Okay, and that is how the entire solution works end to end. Right, so that's how all the components of the solutions comes together, right? And then as you can see, the real value behind using this solution, and which really brings out the power of using Azure Sentinel as a SIEM for your IoT environment. Okay, so the entire solution is hosted on our publicly accessible GitHub repo. Right, so all of the different components that I talked about are available on that GitHub site, together with detailed step-by-step instructions on how to deploy each of these components that are part of the solution. Okay. All right, so enough talk. Let's go ahead and jump into some demos and see how the actual solution looks like when you have it fully deployed in your Azure Sentinel environment. So I'm going to pivot to my Azure portal right now. So before that, let's go ahead and take a look at the Azure Defender for IoT sensor. I'm going to go ahead and log into that and then show you the log forwarding profile that I've set up in there. Okay, so this is going to be the Azure Defender for IoT portal. It runs off a local sensor that you deploy. And then it has a feature down here for log forwarding. So, and then I have a profile already set up in here. When we go ahead and inspect that profile, as you can see, I named it as Azure Sentinel, and then I'm sending everything that is severity level warning and above to a syslog server using the CEF format, and then that is the IP address of my local syslog Linux machine, and I'm forwarding it over port 514, and simple as that, right? And then on the syslog server, I just need to go ahead and deploy um, the collection agent for Azure Sentinel, and then it is going to go ahead and collect those syslogs is receiving and then forward it to the Azure Log Analytics workspace. Okay? And then once you have that connector deployed, right? When we come into logs here, and I can very quickly go ahead and show you where I have my sensor deployed, my function deployed. Let me just refresh this page right here, and we're going to go into logs, and then we're going to go into functions. There we go. And then as you can see, this is where the parser is actually installed. So I'm going to go ahead and load that as code. As you can see, it is targeting the syslog, been sent from Defender for IoT, and then is doing all the necessary parsing, etc. And when I do run this, as you can see, all of my data is correctly parsed and normalized. And when I go ahead and inspect any of these alert logs, as you can see, I can see fields like source IP address, source MAC address, destination IP, destination MAC address, etc. Okay, so this is how the parser actually works. And then once the parser actually normalizes the data, the detection rule or the analytics rule actually picks that up and creates incidents out of them. So over here, I have the analytics rule configured, which is the custom Defender for IoT alerts. And then when I go ahead and edit this, as you can see, when I go into set rule logic, this is where I'm doing the entity mapping based on the fields retained from my parser. And then down here in the alerts detail, this is where we are doing the dynamic field mapping, right? So everything that is present in the alert name column is going to be parsed in as the alert name for the incident that gets created. And same here for the description. Okay, and then the rule runs every 5 minutes, and then it's if it finds any data in the Defender for IoT underscore CL table, then it is going to go ahead and create an incident. So let's go and take a look at how the incident is actually going to look like. So when I go into incidents here, and then let me bring up my last 30 days of incidents. Okay, and let's go ahead and take a look at this right here. As you can see, this is a port scan detected alert coming from Defender for IoT. As you can see, I get all the entity mapping right here. I can click on view full details, right? So I get all the entity names right here, and then I see the alert name right here. When I click on it, and I can scroll down here, and I can see all the additional metadata provided by the rule. I can see the source MAC address, destination MAC address, etc. Right, and then since the entities are correctly mapped here, what I can do is now click on the entity type, the entity name, and then it's going to take me to the UEBA feature for IP addresses, right? And then as you can see, it gives me everything related to that IP address when it was first seen in my environment, when it was first seen by Azure Sentinel, when it was last seen by Azure Sentinel. If it was a public IP address, it would give me all the geolocations for that public IP address as well, and then all the different alerts related to that same IP address, right? So that's one way to do investigation for your IoT alerts in Azure Sentinel. The other one is going to be using the graph investigation tool, which is down here when I click on it. And then as you can see, it gives me the actual alert and then the entities present in that alert. And if I click on any of the entities, I can actually come down here and see the related alerts for that entity, right? And then I'm going to do the same thing for the other one here, right? So as you can see, now I can start constructing the entire kill chain for the alert coming from Defender for IoT, right? So I can see that, hey, this particular original alert port scanned had this particular IP address, and that IP address has got a ton of other alerts associated with it. Let's see this one right here, right? HTTP client error, and when I expand that, as you can see, there is another IP address associated with that alert type. Right, so I can now reconstruct the entire kill chain, see how the attacker moved around my IoT environment, what all they compromised, etc. Okay, so that is going to be the richness of the alert and the incident now coming into Azure Sentinel from your Defender for IoT. And then the next step here is going to be to perform the actual incident response. Right? So before that, I'm going to jump into my IoT service here, and I'm going to show you all the virtual device registrations I have. Right? And then as you can see, there is a virtual device registration called IoT device 2. And then in my alert itself, it is flagging that particular virtual registration, right? And this is coming from the watch list that I've configured. Okay, so basically I know that, hey, this particular IoT device is communicating to this virtual IoT device in the IoT hub. I need to terminate that communication so that it is not able to communicate to my backends, etc. So for that, I have the playbook already deployed, the block IoT device playbook that is part of the solution. And when I go and hit run here, it should actually go and disable that IoT device registration. As you can see, it went from enabled to disabled, right? And only that particular IoT device registration was targeted because it was part of the incident right here, right? Okay, so as you can see, everything works end to end. And then the last part here is going to be looking at the dashboard, which is aka workbooks. So if I go to my workbooks, I've already have it deployed in here, and all of the deployment instructions and everything is available on our GitHub repo site for you to do this. Okay, so it's going to load, and then as you can see, it gives me the first section here is going to be alerts based on subnets. These are the different subnets I have in my IoT environment, my IoT networking environment, I guess. And then these are all of the different alerts, the different counts of those alerts, the IP addresses associated with those alerts, etc. And then top policy violations, top protocol violations, top operational related alerts, and top anomaly alerts in my environment. So full rich dashboard available for you to use here in order to correctly monitor and visualize the risks in your IoT environment. Okay. So that was the demo, and that rounds up the recording for this part 1 of the recording series for the Azure Sentinel solution for Defender for IoT. The next recording we're going to do is going to be the part 2, which is going to be dedicated towards the Azure Sentinel IoT lab, where basically I'm going to walk you through our IoT lab environment, how to set it up, etc. And as I said before, this is going to be a very rich environment that you can deploy. It is going to be a controlled, isolated IoT lab environment where you basically have simulated IoT devices, and you can actually go ahead and launch attacks against those IoT devices and then use that for red team, blue team exercises, use it for SOC training, use it to evaluate Azure Sentinel, use it to evaluate Azure Defender for IoT. You can actually extend this environment, bring in your own IoT devices, have it as part of the lab here, and then do attacks against your own code, your own IoT devices, etc. All of this runs on just a Hyper-V server. That's all you need is just a Hyper-V server, and that's it, right? So no expensive hardware required, and everything is deployed using a script that we're providing. So within 20 minutes, you can basically stand up the entire environment, deploy all these simulated IoT devices, set up your networking, and then add your Kali Linux box and start doing attacks, start performing IoT attacks in the lab environment. Right? So if you are interested in something like this, please watch the part 2 of this recording series. Alrighty, with that brought us to the end of the recording. So if you need to contact us, if you have any questions, etc., regarding the solution, how to deploy it, etc., we are more than willing to answer those questions. We can coordinate calls and help you answer or even deploy the solution in your environment. Okay, so this is our website, www.criticalstart.com, and then this is our email address you can reach us at, which is going to be microsoftteam@criticalstart.com. Alrighty, it was a pleasure presenting our Azure Sentinel solution to you guys, and that brings us to the end of the recording. Thank you.